Hi, my name is Jinyu Wang. In my project, I choose the data from my current lab. Its dataset contains demographic information, scores of Barcelona Music Reward Questionnaire, which measures individuals' ability to derive pleasure from music, and brain morphometry data, which includes brain subcortical volume and cortical thickness. In this project, I included 162 observations in total, with 28 brain subcortical metrics and age as features. In this project, I was trying to find subcortical metrics that are most predictive of individuals' ability to derive pleasure from music, which also refers to music reward sensitivity. Okay, here is my code. So for the data exploration, I plotted histogram to check the distribution of the target variable and plotted the correlation map for numerical features and the target variable. Then I created the scatter plot to look at the relationship between the target variable and other features. Here is a plot. This is a correlation heat map. And these are the scatter plot for showing the relationship between the BMRQ score and the 5 top features that have highest correlation coefficient with the target variable. I also checked the outlier using the IQM method, and the results shows there are some features have outliers. Then I also calculated the variance inflation factor for each features to test their collinearity, and also did chi-square test for the categorical features. So as we can see here, there are some features that have high collinearity. Then I also calculated the skewness of numerical variables to check their distribution. And according to the plot, we can see here some of the features are skewed. Then for data transformation, I imputed the missing data using median imputation, and I also kept the outliers using the IQM method, since some features are skewed according to the results from previous data exploration. And I then selected random forest nasal regression and gradient boosting as the algorithm that used to build individual models, since these 3 algorithms are good at handling high-dimensional and high collinearity dataset, and it can also get feature importance from these models. I then further shaped the dataset to fit the requirement of different algorithms. For the nasal regression, I calculated the skewness of the numerical features, and it turns out that after capping the outliers, these features are not skewed, so there's no transformation needed. I then standardized the numerical variables, and then using one-hot coding for the factor variables that will be used in the nasal regression. And I also then I used the neighbor encoding for the dataset that used in the forest, the random forest, and the gradient boosting. In the next step, I used 80-20 stratified split to split the dataset into chain and test the set by based on the combining of sex and age group. Here are the code for individual models. This is natural regression model, and this is gradient boosting model. I then compare the model performance of these three models using the root mean squared area as a metric. As we can see here, the natural regression has better performance than other two algorithms. For model evaluation, I used a holdout method, which was shown before, and also five-fold cross-validation. After use five-fold cross-validation and hyperparameter tuning, it turns out that the gradient boosting algorithms has better performance than other two algorithms. I also created an ensemble model by combining three models using linear regression and compare the performance of the ensemble model and individual models. As we can see in this table, the ensemble model has better performance than all three individual models. I also use this ensemble model to predict two unseen observations which haven't been used in previous chain, test, and validation. It turns out the ensemble model can accurately predict the BMIQ score. As we can see here, the predicted value is exactly the same as the actual value. Finally, I tried to calculate the feature importance. I averaged the feature importance for brain metrics across three different models. As we can see in the final table, these are the top 10 brain regions that are most predictive of the BMIQ score. Okay, we finally get the top 10 most important features predicting music reward sensitivity. These areas are primarily associated with reward processing and memory in the brain. I have learned a lot from this project, like how to decide which method to use for shaping data based on the data distribution and how to tune the model. However, there's still improvement needed to be done for example, for feature selections and getting the feature importances from the ensemble model. Thank you.